Welcome to the intersection of technology, cybersecurity, and society. Welcome to ITSP Magazine. You're listening to a new episode of Stories from Space podcast, where your host, Matthew Williams, examines the history of human spaceflight, the breakthroughs that revolutionized our understanding of the universe and our place in it, and the brave individuals who work tirelessly to advance the frontiers of our understanding. Knowledge is power, now more than ever.
The authors acknowledge that this podcast was recorded on the traditional, unceded lands of the Lekwungen peoples. Hello, and welcome back to Stories from Space. I'm your host, Matt Williams, and in the booth with me today is Rodrigo Schmitt. He's an aerospace engineer, astrophysicist, and analog astronaut who's dedicated to advancing high-tech and space exploration through computer design, systems engineering, AI, and even has a very, very interesting proposal, which will be the main focus of our interview here today. Hope you don't mind. But of course, yes, we'll be talking about other things. But yes, you have distinguished yourself quite recently by becoming an advocate for using sandbox games to integrate that into spacecraft design and mission design and all that. So, for the sake of my listeners, could you tell us a little bit about the road that brought you to where you are today and how you became a fan of the Kerbal space program?
Yeah, absolutely. Thanks for having me, Matthew. Yeah, KSP has been a game in the back of my mind for quite some years now. Since I was a child, my best friend and I used to play games together, and he would push Kerbal Space Program to me like since I don't know, 2010s or so. But I never really played it extensively until I got to graduate school at Purdue University, where I'm doing a PhD. And my professor actually pushed me into using simulation games to enhance my simulations. So I do a lot of simulation work with space missions and essentially trying to design all the systems that go into a mission and then how we can make the best design choices possible and the best architectural choices. So what are the orbits? What are the different inputs that we put into a simulation so that we can study all the outcomes of a mission, like the cost, the performance, the delta Vs, and so on. So my professor at Purdue, his name is Daniel De Laurentiis, he actually pushed me into using a simulation game environment so that I could distinguish my work in not only doing a simulation from scratch, which would mean like programming every single thing, but actually using something that can give a lot more fidelity to the simulations. And down the line, I could essentially use it for a more realistic environment where I can simulate missions that are more similar to the Artemis missions from NASA, to SpaceX's Starship vehicles, or even the lunar landers that were used historically in the Apollo missions. So KSP came to mind like instantly when he said that he wanted to use sandbox games. And that's how I ended up getting involved with that for research.
Mm-hmm. Yeah. Well, and you mentioned a couple mods and filters that you added on in the game, which other people can use to make it especially realistic. Which ones are those?
Yeah, so in KSP, there are a lot of different assumptions that make the game a little bit more simplified and I would say more gamified. So in the solar system of KSP, you don't really have the real planets. So instead of Earth, you have Kerbin and so on. So in order to have the right scale of the solar system, there is a mod called Real Solar System, where you actually have the distances matching what the distance to the moon would be, to Mars, and so on. So that's just one example of a mod that goes inside what's called Realism Overhaul. So this realism overhaul is a collection of mods that allows you to make all the designs more realistic. So you have real engines is another mod that goes into that collection. You have procedural parts, which is essentially a way to change the geometry more freely and not use specific shapes or forms that go inside the game. And it's very ingenious if you think about it, because if you want to put together parts of a vehicle in KSP, all of these different parts, and they are kind of pre-made in the original game. But it's relatively straightforward for the gamers who have been playing it for decades to take this engine and use the physics-based models in KSP and actually twitch it so that you don't have to have a capsule that is perfectly parabolic, but you can use something that is like a cone, and then you can change the ratios. And that can be said about multiple parts that don't even exist in the original KSP. You can use like electric current, all the bandwidth for the antenna communications. So it allows a new world of possibility just from this collection of mods that people worked very hard for years. So I'd say that that's the main mod that I've been using. But there are a lot of mods that are built on top of that in order to replicate parts and designs from the real world. So one of them is called Artemis Construction Kit, and that's what I use to replicate the design of the Space Launch System from NASA, or the Orion spacecraft, or even some of the proposed lunar landers back in 2015, I believe. That's when they proposed some of the original ones.
Hmm. Well, yes. In fact, as I mentioned earlier, this is something that you have integrated into your own professional work. What are some of the designs you have tinkered with out of interest?
Yeah, yeah. I mean, the Orion spacecraft and the Space Launch System were very challenging in the beginning because even though you're provided a parts of them in the Artemis construction kit, you actually have to build it. And each one of them has dozens of parts, and you actually learn a lot about rocketry and simulation of space systems just by using that. But I think that one of the things that I've enjoyed tinkering with the most in KSP is one of the new studies that I'm doing, which is not published yet, but is essentially trying to find the best optimal design for a model rocket just based on its geometry and the selection of the different subsystems that go into it. So you can choose a specific propellant that goes into the rocket. You can choose how the parts connect to each other, and you can choose the geometry of all these parts. And all of that is going to affect the aerodynamics. So essentially, what's the drag of this vehicle? What's the lift that it can consume? So based on that, that's going to affect the aerodynamic stability during flight, but it's also going to affect the delta V performance of the vehicle. So essentially, how high it can go. And there are many different metrics that engineers use to classify whether a space system is performing well or not. And using those metrics, I can essentially go through the designs using some more advanced AI techniques and train an AI agent to actually find what's the most optimal depending on what requirements we have for a mission. So that has been one of my latest projects in my PhD, and it's been really fun. And like you have a lot of freedom to work with it, which is why I decided to talk about it on top of the actual designs of the systems that I replicated.
Hmm. Yeah, in fact, I first came across your work there as part of the submission you and your team made to the Lunar and Planetary Science Conference this year. The paper rather that you had submitted as to that, and looking into it, you've done this. You made the similar proposals before too, haven't you? about the utility of sandbox games in it. Um, and I have a bit of an admission here. I've never played Kerbal Space Program, and this came up before you and I had a chance to talk. Before I even saw your paper, someone was commenting on another proposal that had been submitted to the recent LPSC, and yes, they thought of it as a result of what they were reading, and they asked me. I assume you've played that before, and I had to admit, no. Then your paper by complete kismet came up, and I had to remind this friend of that conversation. It was like, you'll never believe what I just saw. And yeah, well, and yeah, you definitely made a very good case for how its integration would help. There's also a great deal said about how it is useful as an educational tool, which you guys also mentioned in your submission. Yeah, so there are quite a few proponents now of this kind of what's the term other than sandbox game, the open world, or
Mhm,
yeah,
mhm.
yes, and it is interesting to see that there. But if I'm not mistaken, you yourself and your colleagues, you're the first to say this should be a part of not just education but engineering and design. Is that accurate?
Yeah, so let me put it into some context. Usually in the systems engineering process, when we're designing space missions in NASA or any other space agency or any company really, there is a usually a seven-step process that goes into designing a system and actually launching it. So there's from phase A to phase F. Sometimes there's a little bit of change, but essentially this design is conceptualized in the beginning, and basically some calculations are made on paper or on a computer, and some simulations are done so that you can like a proof of concept of this design. And then, and only then, you actually proceed with going through with refining the requirements, actually building a prototype, and then eventually testing it and launching it to space. So this timeline of how the designing of a system goes really starts with the concept of what you're trying to solve. So this conceptual framework, this ideation process, it can really benefit from using something that is more robust than a back of the napkin calculation, but is not realistic enough for you to actually test whether the model is going to like fly in the real world yet. So this positions it KSP or any other sandbox game platform that is reasonably realistic, especially with all the mods, to be the right tool for you to make the simulations in the beginning and actually say, hey, I've explored like 20,000 cases in which all of these designs could perform well. And I found that this particular set of designs is really meeting all the requirements that we want to fulfill the mission that we need. Especially considering all the different systems that go into the process, because you don't really build a launch system in and of itself. You build a launch vehicle, like a rocket, so that it can transport something. So you're going to have a certain payload capacity to transport a satellite or a lunar lander or a refueling station. And all of these different systems that are actually going up to space are going to affect mildly what the design of your vehicle is going to be. So all of these considerations, they really play a huge role early on when you have to conceptualize all the different systems at once and tailor the designs so that when one of the systems changes, the other one will also change. And it might be between the rocket and the lunar lander, but it might be between the lunar lander and the refueling station, since you might want to do on orbit refueling of this lunar lander in space. So you have to analyze these traits very carefully in the beginning And having a tool like KSP to assist in those conceptualizations and in the design, the ideation phase, can be really, really powerful before you actually commit any resources to developing these in a more realistic scenario.
Hmm. Yeah. So pre-phase A, as you said in your paper, yeah, helping to inform the process in its grassroots stage or yeah, foundational stage. Yeah. Well, that I found that very interesting. And now you specifically mentioned how this integration could really help address a lot of the emerging and innovative technologies that are out there, but which mission planners, using NASA as an example here, that they're not really looking into themselves, that are not really taking advantage of fully. And your focus was on orbital refueling. So yeah, could you tell our listeners why is that such a big deal right now?
Yeah, think about it this way, right? When cars came up to the market, like a couple of centuries ago, I guess, people were really drawn to having a way of um, transporting themselves between places that are far away. But if you can't really refuel your car and you can just go to a place and then come back, and then your car is disposable, you don't really make it accessible to everyone. And the same is said about planes, airplanes, and the same is said about rockets. So we're now seeing a big shift in rocket reusability. And not only companies like SpaceX, but also Blue Origin, and many different players in Europe actually are starting to make a big shift towards reusability. But when we talk about exploring the moon again or going to Mars, things change a little bit because you need a way of refueling stuff that doesn't come back to Earth yet.
Mhm.
So if you have like a lunar lander, this lander might go to the moon, but if you actually have to send it again for a different mission, um, all the costs of sending a new system to space are going to be what's called recurrent. So you're going to have to pay it all over again, have a new launch that's super expensive. So unless you have a way of refuel systems in space, um, exploring the solar system as a whole is basically not going to be possible. And that's also true for satellites. If you have a way of servicing satellites and refueling them on orbit, that's really going to drop the prices, and we're going to see a lot more accessibility to services that are really important to everyday life, such as using internet, using GPS, or looking at your phone and climate data. Over 90% of the climate data that we have in the world nowadays comes from space, comes from satellites. So all the stuff that we use on a day-to-day basis, even what's making it possible for me to talk to you, even though we're like very far away, all of this connectivity is only possible because of the advent of space exploration. And having a cheaper way of making things happen in space is one of the big barriers to actually making space exploration go to the next level.
You said orbital refueling of satellites, and that just got me thinking. That would be a way to ensure that satellites don't go defunct after a set amount of time, and that would really help mitigate the problem of space debris. Wow. I wish we talked before I be finished an episode on that subject there, but yeah, that would represent a big game changing thing in debris mitigation. Wow.
Mhm.
So
That's
yes.
that's actually something that I'm working on with a startup with some friends right now. We started in 2022 um, a way of navigating in space using cameras that can do more precise um, navigation relative to other orbits, other objects, so that you can actually approach them and refuel them. So we've been working on that. We already got some very nice results and grants to actually go through with the idea, and we are developing this prototype so that we can send it to space probably by the end of the year or next year to demonstrate the technology. Just a minor parenthesis since we're talking about it. It's a nice little thing that I'm doing on the side of my PhD too.
Yeah. Well, I'd love to hear about it, further when especially when it comes out. And
Mhm.
yeah, so for your research proposal there, the one that you submitted, a you focused your simulations, which you ran, right? You focused on the Artemis 4 mission, and this was particularly important because of a refueling element that's going to take place. So, yeah, could you walk us through that a little bit there, just for those who aren't familiar?
Yeah, absolutely. So we saw the Artemis 1 mission a couple of years ago, and it demonstrated basically going to the moon, orbiting, and coming back. And the long-term vision of the Artemis missions is to set a presence on the moon again for humans, right? So Artemis 2 is coming up in the next year or so, and the Artemis 5 mission is set for 2030, so a few years down the line. And the big difference that this mission has is the development of a refueling module made by the European Space Agency. It's called the Lunar View. So this refueling module is set to go to the Lunar Gateway, which is basically a big space station, much like the International Space Station, the ISS, but it's going to be located closer to the moon. So the gateway is going to be, like its name suggests, a way of vehicles to kind of like park so that it can have the necessary resources down the line for actually doing transportation between the Earth and the moon. So having a refueling station in the gateway is one of the biggest game changers that can allow a lot of the different systems that are necessary for the operations on the moon to be refueled. So we're talking about lunar landers, we're talking about tugs like the Orion spacecraft that just do the transport in space. So if we can refuel these systems in space, that can really assist in establishing a human presence on the moon down the line. And that is the big vision. But before we can actually get to Artemis 5, there are all these necessary steps to actually build the gateway basic infrastructure in closer to the moon, and then eventually actually establish that well enough so that we can have this refueling module.
Mm-hmm. Yeah, I believe I made a mistake there. I said Artemis 4, but it was Artemis 5 that you were focusing on. Yes, Artemis 4. Well, yes, Artemis 3 is the long-awaited landing and return of astronauts to the moon. Artemis 4 is their first rendezvous with the Gateway, if I recall that correctly. Whereas, yes, 5 will involve, yeah, a test of the refueling module. Yes, in terms of, well, I was going to ask your opinions about, in terms of the Starship HLS, the amount of times it has to be refueled in orbit in order to make the journey to Mars. Is there any consensus at this point as to how many refueling tankers need to be sent up in order to serve as a single HLS?
Yeah, I read a study, I believe it was last year, from a group of researchers at, if I'm not mistaken, it was MIT, that did a study on this exact concept. So how many times the Starship needs to be refueled and what are the costs involved? And if I recall correctly, it was something between 15 and 20 different times that each Starship needs to be refueled. So around 16 times that you have to send the Starship up to space, and then there is basically this upper module of the Starship that's going to be refueled in order to go to the moon and to Mars, right?
So currently, NASA's Artemis program they have the Starship HLS, which is going to deliver astronauts to the lunar surface in missions 3 and 4. Whereas for 5 and I believe afterwards, you have the Blue Origin's Blue Moon lander that's being integrated.
Mhm.
So, yes, what's that going to look like?
Yeah, so with the Blue Origin lander, which is Blue Moon, it was the main lander that I simulated in my paper to Acta Astronautica. So since we're talking about Artemis 5, we have a separate lander that is responsible for the operations on the moon. While in other missions from Artemis, you're going to have Starship, which is both the launch vehicle and the lander. So the operations for a separate lander, which is the case of Blue Moon and Artemis 5, really require a different kind of architecture than what's being planned for the missions that use the Starship from SpaceX, for example, as the human landing system. So if we have a context in which we have a separate lander than the Space Launch System, the Blue Moon lander needs to be reused in on the moon. Essentially, you need to have a way of refueling that in orbit, and the Gateway is the no-brainer option to have a system that goes to the moon and then it essentially ascends to low lunar orbit, goes to where the Gateway is located near the vicinity of the moon, refuels it, and then you could essentially use it all over again. This kind of architecture is something very new, and it has a lot of moving parts. So the refueling module being one of them in Artemis 5. So I believe that a lot of the operations that we're going to see by that time are going to be more on the demonstration side of things than actually fully functional as an architecture. So that might or might not happen, but that is the kind of proof of concept that needs to happen so that we can actually have reusable elements transporting us from Earth to the moon, back to Earth, or between the lunar gateway and the moon, which is the case of a lunar lander. And demonstrating this kind of operations is something that just like takes so many systems, takes so many brains, so many people involved, and hopefully we can see that by the next decade. It's Artemis 5 is scheduled for 2030, but I don't know, like with space missions always have some kind of delay. That is something that can always be expected. But hopefully, by the next decade, we can see some very exciting demonstrations coming up, and down the line, we can see this happening more and more.
Mm-hmm. Yeah, I always had questions about well, the current planning for Artemis 3 onward. Um, Mainly because, and you raised this in your study, you simulated different types of landers, and that included the Lockheed Martin proposal, which was back in 2016, I think, or thereabouts, and one other. What was the second one other than the Blue Lander?
It was the Dynetics one. It's one more
Dynetics.
rectangular and a little bit shorter than the other ones.
Yes, right. The other, yes, the pitch that didn't secure the Artemis 3 HLS contract. Yeah, I always found it odd that they were going with this, but of course it was necessitated that they're going with the Starship HLS here, which would then be left in lunar orbit. So basically treated as an expendable system. But this was necessary because of their expedited timetable and the gateway not being available. I liked the 2016 architecture myself, and kind of missed the idea of the Lockheed lander. That was a beautiful proposal when it came out. Now, have you seen the? Hang on. Uh, Used up a lot of brain cells trying to figure out where we would go back to. Yes, the 2026 budget was recently released by the White House. Now that contained all manner of cuts to NASA funding NASA research and development, including the SLS, Orion, and the Gateway, after Artemis 3. And I guess my question is, how does that factor into your plans there? And is that going to seriously adversely affect the future of the Artemis program?
Yeah, that's one of the big questions that people in the industry are discussing right now, Matthew, because one of the biggest shifts that were are being cut in NASA is the shift from space science to human space exploration. So while there were a lot of cuts in space science research, the Mars Sample Return program, for example, there is also a lot more money that's being invested into human space exploration so that, like, quote, to beat the Chinese back to the moon and like go to Mars eventually. So, and this tug of war between Moon and Mars is something that is still very uncertain. And there are so many different opinions in the industry. There are a lot of people that say that going to Mars first is just not feasible, is something so much more challenging. Going to the moon as a proof of concept would make a lot more sense logically. But then there's a lot of people that say that if Mars doesn't happen in this decade with this administration, it might not happen ever. And we are seeing a lot of attraction from SpaceX, especially to make that happen. So it's a good time to actually push for these changes and for this disruptive exploration of space. So I don't know if there is a clear answer until we actually like see what's going to happen. Personally, I am really enthusiastic about both Mars and the moon.
Mm.
Um, like I grew up seeing not the Apollo era, but just like looking back at all of the landings from the 60s and being utterly mesmerized by all of this amazing exploration of space. So the moon is very dear to me. I even have a tattoo of the moon and an eclipse. Just absolutely love it. But to actually conquer a different planet, which is the planet for Mars, is just something that can really put us in a next level species in space. And I don't know. I'm just really excited about what's going to happen in space exploration. And it breaks my heart that there's a lot of cuts in NASA other than that. But to see what's going to happen, we just have to wait, I guess.
Hmm. I certainly know what you mean. It's a very evolving situation right now. Has been since, yeah, the current administration took over. And yeah, in fact, that tug of war between the moon and Mars, it was a while before I really appreciated how how deep those roots went, right? Ever since the early 2000s, in fact. Yeah, Mars Direct versus step-by-step approach. Yes. Well, so if we were to, let's say hypothetically, down the road when it comes to mission architecture and the design of systems, do you foresee a time when, yeah, this sort of sandbox games with total realism overhauls, that they're a like regular and functional part of what space agencies do?
I I honestly think that a lot of people in these space agencies know about KSP and have used it for education purposes. At some point, not all people, but a lot of engineers. However, one of the big things that I wanted to provide with this paper is not a new means of all these well-established space companies and agencies to do science because they usually have their own platforms, and these platforms, from software simulations, are restricted for obvious reasons. But for the common people, that citizen scientists or just like people that want to explore more, and have new ideas and explore these ideas, it's really hard to have a way of actually doing things um, that uh, so that they can contribute to space exploration. So, what I'm trying to do with this paper is offering a new alternative so that people in general can dig into space exploration more and contribute to the advances in many, many different ways. And the gamers have done that beautifully, very creatively with these mods. I just think that it's kind of untapped. There's a lot of people that know about the game, but they don't know that these mods exist. And having all this collection of mods that I'm using, not only to increase the realism, but also to integrate that in different simulations. So using APIs, for example, like the Kerbal Remote Procedure Call or KRPC, they allow you to take the data from the game and actually include that in your Python, in your C code, and just do whatever you want with it. So what we've been doing in our work, for example, is just taking all of these realistic designs, using them inside the game, and then extracting some of the data so that they can be used in more realistic simulations of the astrodynamics models, the orbital mechanics. It doesn't even require you to fly them in the game in order to make these simulations possible. And kind of like with the paper, we show how that can be done. It's a very steep learning curve. Don't I'll make sure to mention that, but it's very rewarding if you really want to get into the like the deep ropes into how space can be simulated, and this is a very powerful way.
Hmm. Yeah. Now, on a bit of a different track here, um, as I mentioned at the beginning, there you're also an analog astronaut. That is something that certainly is featured prominently in your bio. Um, Now, I made the mistake of thinking that you did your analog training in Brazil, but in fact, it was with the Mars Society. It was at the Mars Desert Research Station. So yeah, mea culpa on that assumption. But yeah, what can you tell us about that? What was it like?
Yeah, so just some background for in the listeners. Actually, Purdue University has an ongoing partnership with the Mars Desert Research Station, in which we send one or two crews every year to actually perform science. So all the students here in the campus are selected by a selection committee that selects the best research proposals and the best well-fitted candidates to perform these research projects. And they might or might not be related to their own research if they're graduate students. In my case, the research that I conducted at MDRS was completely different than what we're talking about with sandbox simulations and artificial intelligence. But what I was doing there was actually as the crew journalist. So I was responsible for journaling down every single day of the mission throughout the 2 weeks. So basically, we are set in a station in the desert of Utah where we can only go outside for EVAs with the use of a mock spacesuit, where we put a helmet that pumps air into our spacesuits, and we need all these authorizations from mission control, and then take some rovers and go to the location to actually conduct whatever kind of science that we want. So in my project, I was using drones to trying to map the terrain of MDRS, which is kind of like a simulation of what will need to happen for the landing on Mars in the future. You need to have a way of mapping the terrain using sensors like lidars. So I probably went in 8 different EVAs or something like that throughout the 2 weeks that I was there. and it was just a very challenging process. Being able to make a scientific experiment happen with minimum resources, not only talking about like the engineering of it, but also connectivity, just not having the internet to look up things while you're coding and make sure that your system can actually work the way that it's supposed to, is just something that the future astronauts are going to have to go through. And the simulation allows you to simulate what are all the steps that go into it, for this kind of high level research to be conducted on Mars.
Mhm. Yes. Well, exciting times ahead. And I do share your sense of excitement and enthusiasm of let's see what's coming. So, yeah, as a bit of a side note and sort of just fun question here, are there any other is there any other gaming platforms or software that you've ever experienced and thought, yeah, this is they get it. Not exactly wholly realistic, but at least very, very good in sort of the world building aspect.
Well, I I think that KSP is definitely my go-to for rocketry, but even though you can also design planes in KSP and space planes, uh, I think that most gamers would agree that that's not its main virtue. Well, like for space science, that is a lot more prominent in KSP. So some flight simulators and that actually simulate uh, not only the process of designing an airplane, but also flying it. Just involves a lot of controls. I think these are very relevant as sandbox games or games in general simulation. There is a Microsoft Flight Simulator in the Xbox, for example, came out I think in 2024. But flight simulators like these are probably my go-to recommendation for people who are interested in sandbox-like platforms.
Hmm. So you can like design your planes and fly them?
Yeah, it
Or
depends on the game. I think that in the flight simulator from Microsoft, I'm not sure you can do both, but it's definitely something that can test out the operations. It could be interesting.
okay. And I want to draw attention to the shirt you're wearing, which yes, yes, Rodrigo was kind enough to put on for those with access to the video, which features, yes, blueprint designs, and these are all the space shuttle. And yeah, in fact, that shows the orbital vehicle at the very top there. There's the orbital vehicle, and it's separate from the tanker.
Yeah, you can just see some different perspectives about it, but you have a good eye there because that is the space shuttle. You can see
Yeah.
the shuttle itself right here on top, and
Hmm.
here in the bottom there is the that huge orange tank that goes into it to carry the shuttle.
Yes. That's lovely, and yeah, it definitely reminds me of your paper. All those lovely little blueprint mock-ups. Well, thank you so much for coming on, Rodrigo. And well, yes, needless to say, best of luck with your future work, and looking forward to having you back on to talk about the orbital refueling of satellites and, well, just about anything else having to do with mission architecture because it is fun and
Yeah,
lovely stuff.
we choose to go to the moon and do the other things not because they are easy, but because they're cool. This
Yeah,
all is really cool. I love it.
yes. And oh yeah, and another one I sort of heard being kicked around. It wasn't, I don't think it was official, but it's like we're going back to the moon this time to stay. I thought, yeah, that's good.
Yes, yes,
And then on to Mars. Fingers crossed. Okay. Well, thank you very much for coming on. And yes, like I said, I hope to have you back, and I'll be in touch with possible days on when we could do that. And well, yes, and of course, any updates from you on like when you've got something to present. Yeah.
yeah, absolutely. Thanks for having me, Matthew. It's a
No,
pleasure to meet
no
you.
problem. Thank you. Be sure to tune in again, where we will have episodes that look at the JWST naming controversy, as well as NASA's budget for the coming year and what it could mean. In the meantime, thank you for listening. I'm Matt Williams, and this has been Stories from Space.
We hope you enjoyed this episode of Stories from Space podcast with Matthew Williams. If you learned something new and this podcast made you think, then share itspmagazine.com with your friends, family, and colleagues. If you represent a company and wish to associate your brand with our conversations, sponsor one or more of our podcast channels. We hope you will come back for more stories and follow us on our journey. You can always find us at the intersection of technology, cybersecurity, and society.